This lesson is about graphing linear inequalities in two variables. A linear inequality in two variables can be written in one of the forms: ax plus by less than c, ax plus by less than or equal to c, and here we have two statements, one for the inequality and the other for the equality, or ax plus by greater than c, or ax plus by greater than or equal to c. Still two statements here, where a, b, and c are just real numbers, and a and b, since they are the coefficient of our variables, cannot be both zero. As in the case of the equations, the graph of a linear inequality in two variables is just the graph of the solutions. Now, what is the idea here? Let's go back to one dimensional. There, we have only one number line, and we want to graph the solution set of this inequality. X is greater than or equal to 1. So what we did there? Since we have two statements, we are interested where is x equal to 1, and we went there and we plotted a full dot. And this is the graph when x is equal to 1. And for x greater than 1, you observe the line, and we know and we see that on the right of 1, there are all numbers that are greater than 1. So we shaded this region. So the number line was divided in two parts. One part where the solutions are, and the other part where the solutions are not. So this full dot divides the number line in two parts, as just we said. And now if we go to two-dimensional, when we have two coordinate system, the equation contains two variables, and for this case we have the fourth forms of the inequality. So ax plus by greater than or equal to c. Now, what is this inequality in two-dimensional? So we see that the coefficient of x is 1, and since y is not present here, we know that b is 0. So we have 0y greater or equal to c, and c is 1. Okay? So now we have a linear inequality in two variables, and since b, the coefficient of y, is 0, it doesn't mean that y will not have a value. Y have infinitely many values, so y is allowed to have all the values. X is fixed only at 1. So we know when x, so the inequality simply becomes exactly the same. X is greater or equal to 1. This is the inequality that we want the graph. Now, when x is 1, we have a line, because not only here, but everywhere, since y is allowed to have all the values, so we have the line x is equal to 1, a vertical line. Now, for the solutions of the inequality x is greater than 1, we are interested only for the x coordinates of the points that are on the right of 1. So for y is allowed to be any value, so we are going up and down from one dimension. So what does it mean? Any point on this, the x coordinate will be greater than 1, and we know. So let me shade this region. Now, this is called the region of solutions. Okay, so we have two regions here in two sides of the line, on the left and on the right. Okay, now let me pick a point here. Let's choose the point 3, 1. Okay, all the points which are solutions to the inequality, the x-coordinate is greater than 1. Okay? But I have to verify this. Is the graph of the inequality correct or not? So, the graph of the inequality in two variables in a coordinate system is a line and a shaded region. So now, based on my previous knowledge, I did this graph. I have to test if this graph is correct or not. And I need a test point, and for this, I will take this, 0.31, and I call this a test point. I want to test, is this point a solution? Is this point satisfying the inequality? I can choose a point in this region. Okay? For example, I can choose point -1, okay, and test this point. But for this case, I will test 3,1, and just to verify that was my graph correct or not. Now, before I'm going to test, I want to emphasize. So the graph of the inequality is a line and a shaded region. So this line is solid because I have the statement of the equation. Now, the graph is a line and a shaded region. This is the graph of an inequality in two variables. Okay? Sometimes the line is solid. Sometimes the line will be not solid because we don't have an equation, and we'll see in this case. Now let me test the 0.31. Is this a solution? To the inequality or not? So I have to write down the inequality, and I need this form. I have x plus 0y is greater than or equal to 1. And now I replace x with 3 and y with 1. And I have 3 plus 0 times 1, which is 3. And 3 is, I don't need this sign here, 3 is greater than 1, so true. True statement. The 0.31 satisfied the inequality. That means my graph is correct. The shaded part of the line, the shaded part on the right of the line is the region of solutions. So I am right. Correct. Now let's go to the other case. What we did in 1D. In 1D, we have only one statement. So we are interested for the values of x that are less than 1. These are the solutions of this inequality. All the points that are to the left of 1. And we test 0, 1, 0, -1, and so on. Now, since I do not have a statement for the equality, I will plot here an empty dot. And this empty dot separates the solutions with no solutions. So the number line is divided in two parts. The same thing in 2D. I need a line to divide the plane in two halves. One half will be for solutions, as we saw in this case, and the other for no solutions. Okay? So now the equation with two variables is exactly the first form. Now, the coefficient of x is 1. So I have 1x. I don't see y here. So b is 0, less than 1. Okay, and now since 0 times y is 0, y disappears, but it doesn't mean that y is 0. Y is allowed to have any value, all the real numbers. Now, I will rewrite again because this is the inequality that I have to graph in a coordinate system. And I'm interested only for the points that x-coordinate is less than 1. Okay? So I need a line that we call boundary line. So the line will be a dashed 1. Because I don't have a statement for the equality, and I am not interested for the points on this line which are solution to the equation which I don't have in my statement. So I'm interested for only points where x-coordinate is less than 1. And the points where x-coordinate will be less than 1 will be to the left of the side 0, -1, -2, and so on. So I'm going to shade this. So even though my job is correct, I have to test, is this the right graph or not? Are in this region the solutions or not? Okay? In this case, I will choose a point on the region where are not solutions, and I choose the point for 0. I like when a point has a 0 coordinate because the job will be easier. Now, but does it matter? You can choose another point. Okay, you can choose 2, 1. It doesn't matter. It matters that I'm choosing at one side of the boundary line. Now let me test for 0. Is a solution to the inequality or not? This is the job of the test. I have to write down the inequality, and then is this. So I have x plus 0y is less than 1. I have to replace now the coordinates. X with 4 and y with 0. So I have x plus 0 times 0, which is 0. So I have 4 less than 1, which is false. A false statement. So this 4, 0 didn't satisfy the inequality. That means 4, 0 is not a solution. Is not a solution. Which means at this part of the line there are no solutions. So I have to go and to shade the other part which I am correctly. Now this is the idea. When we are going to graph a linear inequality in two variables, we need two things. We need to draw a line, okay, which is a boundary line, and this line will divide the plane in two halves. Now, in what part will be the solutions? The solution will be at one side of the line. So we just, after we draw the line, we pick a test point, test this into the inequality, and if this point satisfies the inequality, there are solutions, and we go and shade that part. If this point is not a solution, then we'll go and shade the other part. But let's see this in examples, because by talking maybe we can do something wrong, okay? So the idea is when we work to do two jobs, to draw a line and to shade a part, a part of the plane at one side of the line. Now let's go and see this. Graph the following inequalities. So we have an inequality, and we see we have two statements here, an equation and inequality, okay? Now, the first thing that I have to do is I am going to draw the boundary line. And for this, I need the equation. So 2x minus 3y equal to 6. Now I have this table of value to find some order pair of numbers which are solutions to the equation, and the solutions will be point That will give me the line, the boundary line. Now, if I leave x to 0, if I leave x 0, 0 times 2 becomes 0, and I have negative 3y equal to 6. 6 divided by negative 3 is negative 2. If I leave y equal to 0, 0 times negative 3 becomes 0, so I have 2x equals 6. 6 divided by 2 is 3. Now, if I leave x is 6, 6 times 2 is 12, and 12 will go to the other side with a negative sign, so I have negative 6. And negative 6 divided by negative 3 is positive 2. So now I have 3 pair of numbers in order: 0, negative 2, 3, 0, 6, 2. These are the solutions of the equations. I'm going to plot this on the coordinate system, and I will have 3 points which are enough to draw the line. So 0, negative 2 is here. 3, 0 is here. And 6, 2 is here. Connecting this with a line, I have the boundary line, which is solid, because the equation is in our statement. Okay. Now, where is the graph of the inequality? Above this line or below this line? For this, I need this point, and I'm going to choose the origin. The origin is beautiful. Both coordinates x and y are 0, and I will work faster. I can work faster. Let me write down the inequality. So 2x minus 3y less than 6. So what is the job of the origin? X and y 0. So what I have on the left, I have just 0. Okay? But let me work, and let me say test 0, 0 point. Okay? So I have to substitute x and y with 0. So I have 2 times 0, negative 3 times 0. So this becomes 0. I have 0, less than 6, true. What this means? This means that I'm going to draw, to shade this part of the region when 0, 0 is. Because since 0, 0 gave me a true statement, 0, 0 is a solution. So I will shade the part where 0, 0, the origin is. Because there are all the solutions to the inequality. So each point on this region is a solution. So the coordinates of those points will satisfy the inequality. And I am done. And now I have to say that this is the graph of the inequality. Here are the solutions of the equations. Here are the solutions of the inequality. And together, this is the graph of the given inequality: 2x minus 3y less than or equal to 6. And I'm done. You don't need to write this. You stop here. So 0, 0 is a solution. So you go and shade the part when 0, 0 leaves. Now let me go to the second example. In this example, I have only one statement, so only the inequality. But since I need to draw the boundary line, I need to write down the equation. 2x plus 3y is equal to negative 1. And now I have to fill out this table of values and to have some order pair of numbers, which are the solutions, and will give me points on the coordinate system and therefore the line. So if I leave x equal to 0, 0 times 2 becomes 0, and I have 3y equals to negative 1, and negative 1 divided by 3 is the value of the y coordinate. The y is negative 1 over 3. If I leave y equal to 0, 0 times 3 is 0, y disappear, I have 2x equal to negative 1, and x is negative 1 divided by 2. So x is 1, negative 1 over 2. If I leave x equal to 1, 1 times 2 becomes 2, and now 2 will go to the other side with a negative sign, so I have negative 3. And negative 3 divided by 3 is negative 1. So now I have 3 pair of numbers which are solutions. 0 and negative 1/3, negative 1/2, 0, and 1, negative 1. And now I'm ready to draw the boundary line. Now where is 0, negative 1/3? So negative 1/3 will be here. So this is negative 1/3. Divide the units in 3 parts and take only 1 part. So this is the point. Let me write here. Okay. And I have a point, negative 1/2, which is here. Divide the unit for x in 2 parts and take only 1 part. So this is the point, negative 1/2, 0. And I have a point 1, negative 1. 1, negative 1. Now these 3 points are so close, so let me choose another point. Let me choose another point to have, but doesn't matter. Let me draw. Now, keep in mind, this point will be empty, not full, because this will give me a dashed line. The equation is not part of the statement, okay? So I have a dashed line. Sorry for these points, but just to show you that these are not solutions that we are looking for. Now, at each part of the line, I will have the graph of the inequality, and still I will choose 0, 0, 0, 0 is not in this line. Why not? I will test 0, 0. We call this testing point. If 0, 0 will satisfy the inequality, I'm going to shade the part where 0, 0 is, because here will be solution. If 0, 0 doesn't satisfy the inequality, I'm going to shade the other part. And let me verify this. Let me test 0, 0. Is 0, 0 a solution? Let me write down the inequality, less than negative 1. Let me substitute x and y with 0. So I have 2 times 0 plus 3 times 0, which is 0. And 0 less than negative 1 is false. So 0, 0 is not a solution. Since 0, 0 is not a solution, neither, and the other points that are in this part of the line are not solutions, so I'm going to shade the other part. And now the graph of the inequality is only this shaded region, and not at all the line. The line contains solutions for the equation, which is not in my statement, and I have to write down, this is the graph of the inequality, 2x plus 3y less than negative 1. So keeping this in mind, we have to do 2 jobs: to draw the line, sometimes solid if we have a statement for equality, and sometimes dashed if we do not have a statement of inequality, of equality. Simply equation. Now let's do quickly two other examples, and we are done. So still a statement, a dashed line, no equation. Okay, but I need to draw the boundary line, so I have to write down the equation. If I leave x equal to 0, so if x is 0, x disappears, y is 0. If I leave x equal to -1, -1 times 2 is -2, and -2 will go to the other side with a change sign, so it is 2. 2 divided by -1 is -2. And now, if I let x to be 2, 2 times 2 becomes 4, and 4 will go to the other side with a change sign. So I have -4 divided by -1, it is 4. So I have some solutions here, 0, 0, -1, -2, 2, 4. Let me go and plot them as empty dots, 0, 0, -1, -2 is here. So this was 0, 0. This is -1, -2, and I have 2, 4. And 2, 4 is here. So this will give me a dashed line, because I don't have an equation in the statement, and I'm not interested for the solution that are on this line. So now, since 0, 0 is on the line, it cannot be a testing point, but it doesn't matter. I can choose now any point on this side or on this side, but I prefer a point that has a coordinate 0, so I can test 3, 0, for example, or in the x-axis or in the y-axis. So let me choose 3, 4, 3, 0. Why not? A point on the x-axis when y is 0. And now I have to test. Test 3, 0. Let me write down the inequality. 2x minus y less than 0. Let me substitute x with 3 and y with 0. I have 2 times 3 minus 0, and this is 6, and 6 less than 0 is false. Therefore, 3, 0 is not a solution. So I have to draw the other part of the line. And now this is the graph of the inequality 2x minus y less than 0. Okay, that's it. Let me do the same thing, the last example. So I have two statements, and the line will be solid, so I have an equation. If I leave x equal to 0, this becomes 0, y is 0. If I leave x -3, -3 divided by 3 is -1. And -1 will go to the other side as positive, so y is 1. If I leave x equal to 3, I have 3 divided by 3, 1. And 1 will go to the other side as a negative, 1. So y is negative 1. So quickly I found three pairs of number, the origin, negative 3, 1, and 3, negative 1. So I am going to plot these points, which are solutions of the equations, and this time I have the statement, this will be full points, and then this will give me a solid line. Negative 3, 1 is here. And 3, negative 1 is here. Connecting these 3 points with a solid line, which is the part of the graph. And now I need to test a point. So let me choose a point here, 4, 0. 0, 4, sorry. On the y-axis this time. Okay, I like when a coordinate is 0, when one of the coordinates is 0, or both coordinates are 0, but 0, 0 is on the line, cannot be tested. So let me test 0, 4. Is this a solution or not? Let me write down the inequality. Let me substitute x with 0 and y with 4. So 1/3 times 0 plus 4. This is 0, so I have 4 greater than 0, true. So 0, 4 is a solution. Immediately, happy? I'm going to shade this region. And now the graph is here. The line and the shaded region both are the graph of 1/3 x plus y greater than or equal to 0. Done. So this was the lesson for today. And check your email, because you have to find there the homeworks. And I hope you will be able to do the homework nice work, because this is very, very easy. So see you in the next video.